Just 1 second, I have to turn my tablet around. Yes, now it's better. So the optimization problem oh, this is wrong. Just 1 second, sorry. So the optimization problem of the social planner is given by the following. So the social planner is maximizing over both the amount of steel and fish. So he's maximizing over YA and YB. And he's maximizing the, let's call it the social surplus or the social welfare, which is then denoted by pi s. And it's simply the profits of both firms, so pi A plus pi B. And if we enter the corresponding expressions here, we end up with PA times YA plus PB times YB minus CA of YA minus CB of YA YB. And now you should immediately see why, if we consider this type of optimization problem, so taking a social planner, that the social planner will internalize the negative externality caused by steel. And the reason is simply because now if we maximize this social or the kind of the social welfare function, we not only consider so when we maximize the social welfare function with respect to YA, so the amount of steel, we not only consider the revenue caused by an increase of steel and the cost due to an increase of steel, the direct costs basically, which the steel producer has, but we also consider the negative externality which the steel producer causes for the fish producer. And this will guarantee us that there is an internalization of this negative externality. So to see this, let us consider the first order conditions. So the derivative of the social welfare function with respect to the amount of steel produced is here equal to PA minus C prime A YA minus C prime B 1 YA YB. And again, for notation, since we are taking the derivative of the cost function of firm B with respect to the first argument, which is YA here, I wrote a 1 here to denote this case. And this should be equal to 0. And if you rearrange this, what you get is that PA is equal to C prime A YA plus C prime B 1, or let's put a star here to denote that it's an optimum. So it's a CB 1 prime YA prime star YB. And now what we have is that the amount of steel in the social optimum is chosen such that the marginal revenue is equal to the marginal costs of the steel producer plus the negative externality in, so this is strictly positive here, so the negative externality caused on the fishery. So here it's basically explicitly considered that there is a negative externality. And hence the amount or the quantity of steel will be lower compared to exercise 2 where we had a competitive equilibrium. So next, let us look into the derivative of the social welfare function with respect to yb. So let me change the color. So let us take the derivative of the social welfare function with respect to yb. This is then equal to the following: pb minus c prime b2 ya yb. This should be equal to 0. And if we rearrange this, we end up with pb being equal to cb2 prime ya yb star. Okay, because now we consider the optimal quantity of fish in equilibrium. And as you can see here, there is basically no change with respect to the competitive equilibrium first order condition. If you just look at this necessary condition here, because there is no externality that the fishery is causing on the steel producer. Yeah, so there is no, and hence this condition here is equivalent to the condition that we had in sub exercise 2. Now, if you want to explicitly see why, so a mathematical argument on why the quantity of steel produced here is different than the quantity of steel produced in sub exercise 2, let us do the following. Let's denote this further condition, this first order condition here for the steel producer by condition 1. And then let's consider this here to be the condition number 2. And let's do the following. So from what we know from 2 is that the optimal quantity in the competitive, so the optimal quantity of steel in the competitive equilibrium fulfills the following: ya, and now it will be a little bit confusing because I will use a star here again. So sorry for this. Let's just go back and change the social optimal quantities here. Let's put a tilde on them and not a star. So it will be a tilde here, tilde there, and tilde here. So what we know is that ya star in the competitive equilibrium is chosen such that it's equal to the inverse of the marginal revenue, marginal cost of firm A applied on the competitive price for steel. And what we do is we simply plug in this here, so kind of this expression here for ya star, we plug it in for ya tilde in condition number 1 here. Let's do this. So what we get, let me just write it down. So plug in ya star in ya tilde in 1. Because what we then get is the following. So we get PA minus C prime A of ya star yeah, because we plugged in for ya tilde now, minus c b1 prime ya star yb. And note that this here, so ca prime ya star is if we plug in for ya star the following, so it's ca prime applied on ca prime inverse of pa, and this is equal to pa. And hence we have pa minus pa, and this is equal to minus c prime b1 ya star yb, and this is clearly strictly negative. Hence, the quantity that we receive in the competitive equilibrium, so the quantity of steel which is produced, does not fulfill the first order condition of the social optimum with respect to the amount of steel produced. Yeah, because the condition would be strictly negative if we would plug in for the respective value of the competitive equilibrium, and hence it cannot be socially optimal. Yeah, and this is a mathematical argument that one can make kind of in order to show that it's actually strictly lower. And it is strictly lower because this amount here, so if we would like to reach the social optimum, this term here, so this is strictly negative, so we need to kind of decrease the amount of ya such that this term basically disappears at some point, or cancels out at least with the other points in the first order condition for the social optimum, which was described here. And yeah, this will basically lead us to the social efficient amount of steel which is produced, where we care about the negative externality imposed on the fishery. Okay, so let's write down an answer. So quantity in, or let's write it differently. Let's write immediately pollution in social optimum is lower than in the competitive equilibrium. So this should be simply a V. And yes, that's it with respect to sub-exercise number 3. So this brings us to the last sub-exercise for exercise number 1. So let's have a look. So we have the following. Find the unitary tax, Pigouvian tax, on pollution that a public authority can impose in order to restore the social optimum level of pollution. What are the key informational requirements for the public authority needed to determine optimally such tax? And what we will do is we will think about a tax. So now a tax on firm A, on pollution, which is then paid by firm A, such that the firm fully internalizes the negative externality which it is causing on firm B, and hence the fishery. So yeah, let me write this down here. So, oh, sorry. So it should be somewhere here. We can go up. Okay, so we have more space. So this is sub exercise 4. So the idea would be, so what can we do? What can we do in order to kind of transfer the first order condition in a competitive equilibrium when we're allowed to impose taxes? So what can we do in order to get this first order condition here looking more like the first order condition here? So what are we able to do? So we can impose a tax, okay, so a unit tax. And why shouldn't we choose a unit tax which is kind of making sure that whatever the steel producer is optimized, like however it's optimizing, it has to internalize the costs which it is imposing on the rival firm, so on the steel and the fishery. So the idea would be to consider the following per unit kind of unit of pollution tax for firm A. So consider a per unit unit tax or unit pollution tax for firm A given by TA being equal to C B1 prime YA tilde and YB tilde. Okay, so the tax is equal to the negative externality that firm A is causing on firm B in the social optimum. Okay, so this is why we have the tildes here. YA tilde and YB tilde denote the corresponding values in the social optimum that we calculated in exercise 3. And I think in the solution manual, in the solution PDF, I'm not using tilde, but I'm using I'm not using tilde, but I'm using YAS and YBS. But yeah, just to be consistent here, I will keep on using tilde, and in the solution PDF, it will be an S there. Yeah, so don't get confused due to this. So if we have a per unit pollution tax given by this here, let us have a look on the optimization problem of firm A and firm B. So what is firm, just zoom in a little bit. So what is firm A doing now? So optimization problems. So firm A is maximizing over YA, and it's maximizing its profit, which looks now like slightly different than the profit that it had in sub exercise 2, because now it gets, for each unit of steel that it's selling, it's getting PA, but from this we subtract the tax TA. And this we multiply with YA minus the costs that the firm has. So it's CA YA. And now, if we plug in for TA, what we get is PA minus CB1 prime YA tilde YB tilde times YA minus CA YA. And if we take a look on the optimization problem of firm B, it's still the same. Yep, so firm B is maximizing pi B, and pi B is equal to PB times YB minus CB of YA, YB. Now, if we take or consider the first order conditions, what you will immediately see is that the derivative of the profit of firm A, so the profit which considers the tax or like a pollution tax, then the first order condition is given by the following. So now we have PA minus CB 1 prime YA tilde YB tilde minus CA prime YA. This should be equal to 0. And as a second first order condition, what we have is PB minus CB 2 prime YA YB should be equal to 0. And now if you take a close look, what we will have is that the set of first order conditions which we have here is equivalent to the set of first order conditions that we had in sub exercise 2, where we talked about the social optimum. And as a consequence, the solution, so any tuple of any tuple of YA and YB, which are fulfilling those two first order conditions here, are the ones which fulfilled the first order conditions here in the social optimum. And hence we made sure that the steel producer fully internalized the negative externality on the fishery by this Pigouvian tax, which is just making sure that you tax in a way that you reach the social optimum. But of course, like what's the assumption in order to be able to impose this Pigouvian tax? So the tax is equal to the negative externality. So to some extent, it's proportional to the negative externality caused on the fishery. So what does the government or the social planner or whoever is choosing this tax need to know? So in order to be able to impose such a tax, the government needs to know the cost functions of both firms and the market prices. So even if this kind of Pigouvian tax seems to be very appealing to solve this negative externality problem that we have in this model, there needs to be kind of a very crucial assumption with respect to the information set of the government. So the government needs to know about the form of the cost functions and the market prices. So knowing the market prices is not a very crucial assumption because this is something that a government could estimate quite easily, I would say, or at least it's more easily knowing about the market prices than knowing about the cost functions. So cost functions is a little bit more difficult because typically this is more private information of the firms themselves, so their technology, which they have better information about than the government. So the government could apply some techniques in order to estimate the technology and the cost functions of the firms, but it's very difficult. And not only does it need to estimate the cost functions, so in terms of the direct costs caused by production, but it also needs to find out about the exact amount of negative externality which is caused by the steel producer in this example. And this is a quite restrictive assumption. So if there is not full information about the cost functions here, it's very unlikely that you can apply this Pigouvian tax in order to solve the issue with the negative externality. And this finishes sub exercise 4.